Welcome back. In this section, we will introduce you to transformations of functions. What does that mean? Well, if I have the graph of a function and I want to use that graph to obtain the graph of a new function. So it's obtaining the graph of a variation of that function. Before we actually consider transformations of functions, we want to be familiar with what I call basic functions, the graphs of basic or common functions. And actually, you really need to be able to visualize the graphs of these functions without having to create a table of values. You really should know them. If I say, what is f of x is equal to c, what is the graph that, you should be able to visualize the graph. So let's review the graphs of these common functions. So f of x is equal to c means that c is some number. Let's say c is here. So let's say that c is 5. So we have f of x is equal to 5. So it's going to be, so at 5, it's going to be a horizontal line through 5. So this is the graph of the function f of x is equal to 5. Depending on c, so it's the constant, so it's going to be a line through whatever the value of c is. In this case, c is 5. So that's the graph of f of x is equal to c, that horizontal line. In the next case, we have f of x is equal to x. F of x is equal to x is going to be, that means that whatever x is, y is also. So it's going to be, for instance, points on this line would be 1, 1, 2, 2, 3, 3. So it's going to be 0, 0 is on the line, 1, 1, 2, 2, 3, 3, 4, 4. And so it's going to be this line. So this is going to be the graph of the line f of x is equal to x. For the next function, f of x is equal to the absolute value of x. So again, we know that the absolute value of 0 is 0. The absolute value of a negative 1 is 1. The absolute value of 2 is 2. So it's going to look like this, as you well know. The absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is, and so forth. Alright, so this is your absolute value function, the graph of the absolute value function. The next function, f of x is equal to x squared. So we know that this is a quadratic function. When we graph this, we're going to get the parabola. Yes. So this is f of x is equal to x squared. The square root function, f of x is equal to the square root of x. Square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So the graph of the square root function is going to look like this. The next graph is f of x is equal to x cubed. All right, so 0 cubed, so it's going to look like this. All right, so that's the graph of f of x is equal to x cubed. Last example, this is f of x is equal to the cube root of x. Let's just extend this a bit. The cube root of x. All right, so if we were to graph this, it's going to look like this. So these are the graphs of what I consider the basic common functions, and we will need to use these graphs to make transformations, to determine the graphs of transformations of these common functions. So let's consider what a vertical shift would be. If we have the graph of f of x, here it is, f of x, y is equal to f of x, and we wanted to obtain the graph of f of x plus c, well, this would be a shift upward, a vertical shift upward c units. Here it is. And so this is f of x, so if we shift the graph of f of x c units upward, then we obtain the graph of f of x plus c. On the other hand, if we want to consider the graph of f of x minus c, and we're going to use what we know about f of x. So if I actually take the graph of f of x, here it is, this is the graph of f of x, and now it's minus c, so I'm going to shift it c units downward. So this would be c units downward, and the graph in blue would be the graph of f of x minus c. Now let's consider an example. We're going to use the graph of the absolute value function to determine or to obtain the graph of another function, g of x is equal to the absolute value of x plus 3. So we are going to use the graph of the absolute value of x to obtain the graph of g of x, which is the absolute value of x plus 3. So the first thing we want to do is, so the absolute value of x, or again, you recall that graph of that common function, the absolute value of x, you should be able to visualize it. So here it is. All right, so that's the absolute value of x. We want to now obtain the graph of g of x, which is the absolute value of x plus 3. So that basically means that we want to shift the graph of the absolute value function 3 units upward. So if I go up 3 units, one, two, three, and then the graph is this. So this now is the graph of g of x, which is the absolute value of x plus 3. Let's consider another example of a vertical shift. So we are going to use the graph of f of x is equal to x squared to obtain the graph of g of x, which is x squared minus 2. All right, so the first thing we want to do is to graph x squared. F of x is equal to x squared, and as you visualize, you know that x squared, this is a parabola. All right, so this is the graph of f. To obtain the graph of g of x, we're going to shift the graph of f 2 units downward. That's the downward translation, 2 units downward. So 1, 2. So it's 1. All right, so this would be the graph of g of x, which is x squared minus 2. So that was a vertical shift 2 units downward. Welcome back. Let's now consider horizontal shifts. So let's assume that we have the graph of a function f of x. We have the graph of f of x. And we want to use the graph of f of x to obtain the graph of y is equal to f of x plus c. All right, so this is going to be a horizontal shift. A horizontal shift would mean that we are moving along the x-axis. So f of x is equal to x plus c is going to be, we're going to obtain the graph of f of x plus c by shifting the graph of f of x. Here's f of x, so I'm going to shift it c units to the left. If I shift it 2 units to the left, here we are. So this is the graph of f of x plus c. On the other hand, if we have the graph of f of x, y is equal to f of x, and now I want to consider how do I obtain the graph of f of x minus c using the graph of f of x. So here's the graph of f of x. If it's x minus c, so I'm going to shift the graph of f of x c units to the right. All right. Upon shifting c units to the right, I then have the graph of y is equal to f of x minus c. So this is a horizontal shift c units to the right. Let's consider an example, a concrete example. I'm going to use the graph of the square root of x to obtain the graph of g of x. G of x is defined to be the square root of x minus 4. So we're going to use the graph of the square root of x to obtain the graph of the square root of x minus 4. So let's begin with the graph of the square root of x. F of x is equal to the square root of x. So we want to graph f. The square root function looks like this again. We have, all right, that's the square root function. We're going to use the graph of the square root of x to obtain the graph of the square root of x minus 4. But notice this is of the form f of x minus c, which suggests that this would be a horizontal shift c units to the right. C in this case is 4. So beginning here, we're going to shift the graph of f 4 units to the right. All right, so. All right. So this now becomes the graph of g of x. G of x is equal to the square root of x minus 4. In the next example, let's consider combining the two shifts, the horizontal and the vertical shift. So we have a graph where we will need to execute both a horizontal and a vertical shift. So of course, we're going to use the graph of the square root of x, and we can visualize, we know how to graph the square root of x. Here it is. Square root of x. We're going to use this graph to obtain the graph of h of x. In h of x, it says the absolute of x minus c. Again, c is 1, so that's going to be a horizontal shift 1 unit to the right. All right, so 1 unit to the right. 1 unit to the right. All right, here it is. All right, although we're attaining something that looks like this, that's not our final graph. Because now that we've done the absolute of x minus c, we need to take into consideration the vertical shift. So that's minus 2. So that means that from this point here, we want to take this graph from this point and we're going to shift it 2 units downward. So 2 units downward would be here. Everything else remains the same, so 2 units would be here. So the graph is going to look like this. So this now becomes the graph of h of x, which is the square root of x minus 1 minus 2.